Welcome to CW 1.5. Today we're going to refresh what you've learned about quadratics. So first, let's talk about vertex form. Vertex form is going to be y is equal to a quantity x minus h squared plus k. Don't forget that squared right there. A lot of people often forget that. It's called vertex form because we can see the vertex here. The vertex is going to be hk. So in terms of usefulness, this thing is the most useful form we have for a quadratic. Standard form is what we see most commonly. That's going to be y is equal to ax squared plus bx plus c. And it's standard just because it's very common. It's actually not that great, but it is important to know how to work with it. And then we have a vertex formula. That's going to be how you can generate it from standard form. That's negative b over 2a. That's your x value. And the y value is when you plug it in. So f of negative b over 2a. So those are the three things we need to complete this worksheet. So from there, let's do a couple examples here. Graph these quadratic functions. Okay, so first, let's notice this is vertex form, which is great, because that would mean the vertex is 3, 8. So if you have your vertex already, that's already really good. We only need a couple more things to graph it. We need the x-intercept. So the x-intercept is when y equals 0. So imagine you just plug in 0 for y. Solving this equation is pretty easy. Just move the 8, so negative 8 is equal to negative 2, x minus 3 squared. Divide by negative 2, so x minus 3 squared is equal to 4. We square root this. Now this part I'm not too sure if algebra teacher covered. The root of 4 is 2, and only 2. The root of x minus 3 squared is the absolute value of x minus 3. So in pre-calc especially, it's important for you to know this fact because this is what generates the plus minus. So now you write x minus 3 is your plus or minus 2. So x should be 3 plus or minus 2, which means the intercepts are 5 and 1. And our y-intercept, we can do that by inspection. Just let x equal 0. So that would be negative 2 times negative 3 squared plus 8. So that'd be negative 18 plus 8, that's negative 10. Now with these three facts, we can graph it. So the vertex is 3, 8. So 1, 2, 3, there's 8. I know my x-intercepts are 5 and 1, so I can put 5 and 1. And the y-intercept is negative 10, so I have that right there. And notice how we can graph it like that. Something like that. So there's our first one. Okay, now let's look at our second example. X plus 3 squared plus 1. So the vertex, you can already see it. That should be negative 3, 1. The x-intercept, this is going to be interesting. A couple of you may already notice. If 0 equals x plus 3 squared plus 1, that would mean negative 1 is equal to x plus 3 squared. When you root this, this is not going to work. So there's no real answer for this. Therefore, there's no x-intercept. And the y-intercept, again, we'll do that by inspection. Just plug in 0, we can see it's 10. So for this one, I'll do this in blue. Negative 3, 1 is your vertex. So I'll go negative 3, 1. There it is. And then the y-intercept is 10. I can show you a trick for how to get those other points. There is a pretty easy way to do it from the vertex point. The a value is 1. So the way it works for pretty much any parabola is that if you have your vertex here, your next points are going to be 1 over an a up, 1 over a up, like that. So since a is 1 here, I can simply do this. 1 over 1 up, 1 over 1 up, and then graph it. So even if I didn't have that 10, I could do that. And notice how we could have also done that on the other one. We see a is 2 here, and notice how both points are there. 1 over 2 down, 1 over 2 down. So it's kind of a shortcut. So I'll call that our shortcut for graphing. Now here's our last one. This one we can see that it's in standard form, so it's much harder to see the vertex. In a situation of standard form, you could complete the square. What I'm going to have you do is just use the vertex formula. That's opposite b over 2a. So opposite b would be 2 over 2a is negative 2. That means the x value is negative 1. Let's plug in negative 1. Negative negative 1 squared plus 2 plus 1. This would be 3, and that's negative 1. That's positive 2. So negative 1, 2 is our vertex. Okay, now you're probably wondering, how is that helpful? I'm going to show you. If you think about vertex form is this: ax minus h squared plus k. If you have the vertex, notice how I can actually plug that in. If the xy is negative 1, this has to be plus 1, and the k has to be 2. The only issue is you don't know a, but this is what a lot of people don't know. In vertex and standard form, these a's are identical. They equal each other, which means you know a. It's actually negative 1. It's right there. So get rid of that. And look, there's your vertex form. No problem. So if I want to graph this, pretty straightforward. The vertex is negative 1, 2. So I go negative 1, 2. Maybe I'll do this one in red. And I can see my a value is negative 1. So I'm just going to go over 1, down 1. And I'll sketch my parabola. So I can see already the x-intercept is not very clean. The y-intercept, I can actually see it from the graph, but let's still calculate it. For the x-intercept, you always want to calculate it from the vertex form. It's going to be much easier for you, because if we did it from this form, you'd have to do the quadratic formula, and you want to avoid that when you can. So notice how if you do it from vertex form, how much easier it is. I can write 0 equals negative x plus 1 squared plus 2. So x plus 1 squared must equal 2. Root that, absolute value, so x plus 1 must be plus or minus root 2. So there's our x-intercepts, negative 1 plus or minus root 2. That's why in our graph it's not very clean. And the y-intercept, even though I can kind of see it on the graph, we still want to verify it. Plug in 0 right here. That'd be negative 1 plus 2, and that's positive 1. And there's our 3 graphs. There's our first one, here's our second one, and there's our third one right there. Here's our last example. Consider this quadratic, and we're not going to graph. It says determine without graphing whether it has a min or a max. So for A, all you gotta do is think the two possibilities. This one has a min. That's a positive parabola, meaning a is greater than 0. This is a max, meaning a is negative. I can see here that a is negative. So this question clearly has a max. And again, a is negative, therefore max value. Okay, B, find the min or max. So we'll cross out min and we know it's a max. Determine where it occurs. If you ever see this, that just means find the vertex. And we know how to do that. We have our vertex formula. So So let's do opposite b. That's going to be negative 6 over 2a. 2 times negative 3. That's going to be 1. Now remember, that 1 is the x value of the vertex. That's your x value. To find the y value, you got to plug it in. Okay, so plug in 1 right there. So negative 3 plus 6 minus 13, that's negative 10. Once you have the y value, this thing right here, that is what you want. That's the actual max value of the graph. And then part C, domain and range. Domain's easy. For any parabola, it's going to be everything, all real numbers. And then to find the range, look at what you did in B. This is going to be important. The vertex is 1, negative 10. So if you want, you can sketch it. 1, negative 10 is going to be somewhere in quadrant 4, something like that. And has a max, which means it opens down. So you want to use that mental picture to get the range, because now you can see it's going to be negative infinity all the way to negative 10 inclusive. And now you're done. Okay, let's work on the other questions. Let me know if you have any questions about this video.